Good afternoon. My name is Eshraq Refaee, a PhD student at Heriot-Watt University, Edinburgh, Scotland. People have usually used supervised learning methods to carry out subjectivity and sentiment analysis, since they seem to be more robust in handling this task. However, when applied to a social network like Twitter, actually, the traditional supervised learning methods have shown to be problematic as the models become less able to generalize well to previously unseen topics. And one possible solution for that is the use of distance supervision approaches, wherein the sentiment classifiers will learn from a larger amount of automatically annotated data sets. And today's talk will be about exploring the possibilities of adopting the distance supervision approaches to Arabic. So the first part will be about I will be introducing the topic by explaining the challenges and the techniques of it. So when we talk about sentiment, they might actually have a broad definition as they represent our perception of the world and our personal attitudes and emotions towards some entities and their aspects. And the research of subjectivity and sentiment analysis is actually concerned about studying and analyzing the sentiment orientation of a given text and determines whether a given text is subjective or objective, and for subjective text, whether it's positive or negative. In this work, we are particularly interested in Twitter as the 7th most popular website in the world, with more than 600 million active users and nearly 60 million tweets per day. Since March 2012, Twitter has become available in Arabic, among other languages such as Farsi and Urdu. Arabic comes as the 6th most popular language in Twitter, representing nearly 6% of overall Twitter stream. And one of the biggest challenges with Twitter is its scalability, as it covers almost every domain. So people can discuss endless number of topics on Twitter every day, which creates a problem and difficulty in creating training examples with sufficient coverage to cope with the time-changing nature of Twitter. Another problem with Twitter is Twitter's genre, Twitter's language is being characterized in the literature by being bad language, and by bad language we mean that it can involve misspellings, spelling variations, abbreviations, slangs, etc. Also, the carrying out subjectivity and sentiment analysis on Twitter is not a trivial task, given the complexity and variability of sentiment indicators that a single tweet can have. For example, a tweet can convey emotions in an indirect or unclear way, or even it can convey mixed emotions, or in more complex cases, it can be used to convey irony or sarcasm. So we tried to consider an alternative approach of obtaining the training examples, hopefully automatically, and that is through the distance supervision approach. Distance supervision is particularly useful in the cases where we have a large amount of freely available data, but the labels are expensive to obtain, which is always the case with Twitter. The idea behind distance supervision is actually behind exploiting existing features, such as the presence of emoticons or sentiment-pairing words, and use them as an author-provided sentiment indicator, assuming that users have used these emoticons to mark up the emotional states of their own text. So the big advantage with this approach is the ability of automatically obtaining sentiment labels for relatively larger training data sets. And distance supervision approaches have been successfully used to automatically annotate larger scale data sets in other languages such as English and Chinese. And this work we are trying to explore the possibilities of adopting this approach to Arabic. Now I'm going to talk about the experimental setup that we have used. This was supposed to be animated, it just because I asked the presentation to be a PDF, so I'm sorry about this. So we are not aware of any publicly available Arabic Twitter corpus annotated for subjectivity and sentiment analysis using distance supervision approaches. We started off by collecting our own corpus. So we started by collecting unlabeled tweets from the public stream. And then instead of the manual labeling, this should be again animated. It will be replaced by the automatic process of obtaining the sentiment labels through the presence of sentiment pairing words or emoticons. And then for the labeled tweets, we'll be using publicly available linguistic resources to extract feature set. And then we will be applying machine learning schemes to learn statistical classifiers, and finally we'll be evaluating the generated model. The first dataset is the emoticon-based distance supervision dataset, and it was built based on the presence of positive or negative emoticons. So if a tweet is having only positive emoticon, it will be assigned a sentiment label of being positive. If it's having only a negative emoticon or emoticons, it will be assigned a sentiment label of being negative. If it's having both, it will be excluded from this set of experiment. The diagram shows the distribution of the sentiment labels, where the polar class represents adding up the instances from the positive and negative instances, and the neutral class represent tweets that were collected from official news accounts such as BBC Arabic. And in the lexicon-based distance supervision dataset, simply how it works is that we look up the polarity of word tokens used, making up the tweets in a polarity lexicon with a predefined sentiment orientation. Maybe we will be using the coming up lexicon. So for this purpose, we have employed two publicly available lexicon, Arab Sinti and Arabic Modern Standard Arabic Subjectivity Lexicon, and a translated version of the English MBQA, Subjectivity Lexicon MBQA. So the two lexicons were merged and the repeated tokens were removed, and then we have used the merged lexicon to obtain the sentiment labels in this approach with two different settings. The first setting is the lexicon-based, lexicon presence, and when this approach, actually, for each given tweet, we look up the presence of a sentiment pairing words from the merged lexicon, and if a tweet is having only a negative word or words, it will be assigned a sentiment label of being negative. If it's having only a positive word or words from the merged lexicon, it will be assigned a sentiment label of being positive. If it's having both, it will be excluded. The second setting is the lexicon aggregation. So the lexicon aggregation, again, for each given tweet, we look up the presence of a sentiment-bearing words from the merged lexicon, and this time each sentiment-bearing word will be assigned a numerical score for positive one if it's for positive words, and -1 for negative words, and the overall sentiment orientation of a given tweet will be calculated by adding up these numerical scores, and the automatic sentiment label will be obtained based on the sign of the overall score. If the overall score is positive, then it will be assigned a positive label. If the overall score is negative, it will be assigned a negative label. If the overall score is 0, it will be excluded. All sentiment-bearing words used to obtain the sentiment labels were normalized by being replaced by a placeholder in order to avoid biasing the data set. And this is the size and the distribution of the sentiment labels in the lexicon-based distance supervision datasets. And finally, we have an independent held-out test set that we collected separately and manually annotated to evaluate the models. For classification, we have used support vector machines, and for defining baselines, we have used the majority baseline and a previous supervised learning baseline. So the table shows the results of the experiments we have run, and the columns displays the approaches we are comparing, and to baselines we have got. So from the table, we can see that for subjectivity classification, all of the distance supervision approaches have significantly outperformed the baselines. However, for the sentiment classification, the performance dropped significantly to either below the baseline or very close to it. We have also conducted a blind comparison to compare the approaches against each other, and we found that the emoticon-based and the lexicon presence seem to be equally good, and the lexicon aggregation approach seemed to be the least performing. So the problem to point out here is that we found that the sentiment classification seems to be the most problematic and challenging, and to gain a better understanding about the difficulty associated with the sentiment analysis, we have conducted an error analysis in which we have manually examined a sample set of 300 tweets from the data set. We have manually examined a random sample of the data set. So the first problem we found is the lack of independence of the emoticons used to obtain the sentiment label from the accompanying text. And it's clear in the cases where we have use of sarcasm and irony, emoticons tend to be used truthfully to tell the reader that the rest of the text is being used sarcastically. And in order to avoid biasing the dataset, we had to remove emoticons used to obtain the sentiment labels, which might result in losing very informative bit of the contextual information. Another issue we found is that the cases where the random sample was manually annotated, so the cases where the automatic label were more than the cases of the automatic label matches the manual label matches the automatic label. So we turned it to consider the possibility of emoticons being mistyped, considering the right to left direction of writing Arabic. As we can see in these examples, as we assume they are not sarcastic, they are just being mistyped. Another issue was with the Arabic writing convention for writing quoted text, is that the first bit and red was misinterpreted as being a negative emoticon. So in the following up experiments, we need to consider this pattern and exclude it. The same for the lexicon-based approaches. We found that normalizing the words that used to obtain the sentiment label resulted in losing informative bits that would be very important clues for the classifier. Currently, we are conducting further investigations to try to overcome the issues of heavily relying on word-to-game-based features or trying to use alternative features like whether a tweet is being retweeted or favorited, just an alternative way. Another thing, we were trying to investigate the role of adding more data and see the impact of that on the overall accuracy. And finally, we hope to be able to release this data set soon. Thank you.
Thank you very much. And we actually have 5 minutes for questions. So please.
Thank you.
One of the interesting questions would be like, which part of the sentence would the emotion be most linked to? Like which concept or which part of the sentence would this emotion be most linked to?
Actually, we are doing an overall sentiment classification for the entire tweet, not aspect level, if that's what you're asking about. So we are just considering the overall sentiment orientation of a given tweet, not associated with a specific term or something.
I have maybe a question and a comment. For the literature review, you mentioned Arab, or you actually, the resource you used, Arab sentiment. Is that the same as Sifat, you know, or?
Actually, I think this is the one that was before Sifar, maybe. Actually, I contacted Abdelmajid personally, and this is the one he gave to me. He was nice enough to give it, but this is what I got from him. And it was called Arab Sinti. I don't know if it's a developed version of Sifat or...
It's giving it a new name, okay, possible.
No, I think it's Arab Sinti. Maybe Sifat is an older version of it. I'm not quite sure. But this is what Abdelmajid recommended anyway.
For us too, but anyway, so we'll figure out which one is the most recent. The other, maybe a comment for aggregation.
Right.
What we have tried actually, adding the sentence score to pass the sentence seems to not do very well. Well, what we have tried to actually use the three scores separately. The sum of the positive, the sum of the negatives, and the sum of the neutral. So, and those actually, but those for us scores is the probability score. So if you know the percent word that you have the probability of this word being 0.6 positive, 0.4 negative, 0.1. So if you add those scores, this seems to do reasonably well. Actually, in the other, it seems like this is coming to be the higher baseline. So if you want to see if your method works better, try this first and then see if you can beat it.
Yeah, maybe, thank you for bringing that up. Maybe, it's worth trying. It's just the methodology we have used is just +1, -1, this adding up these numerical scores. It was successfully applied in English and work to Beidou, and I know. It just it was one of the most cited works. So as I said, in this work we're trying to explore the possibilities and suitability of adopting this Arabic in different ways. Yeah.
Thank you for the nice presentation and very good examples you mentioned. So actually I have been working with the architects for the last 3 years from the retrieval point and the filtering point, but I have been trying to do some sentiment analysis, use one of the sentiment analysis available for tweets. And honestly, I have been always finding it to fail. Not because the approach is bad, but because the assumption from the beginning, I think, is not correct. Arabic tweets, positive and negative, is not the best sentiment analysis for it. I think it should be sarcasm or support. We have did this experiment several times. One of this was Egyptian elections in 2012.
Right.
And I can tell you 90% when you find happy emoticon, it's a sarcasm, which is a negative. So people don't attack. They will not find people on Twitter cursing. It will be not that much. But mainly they are doing fun. If they hate somebody, we make fun of them.
Yeah.
This is I think this is the normal in the articles. And the example used is very nice. And this is the actual. It's not 5%. I think it's 95% or something.
Yeah, it was just a random sample that we selected, and this is 5% of the random sample, not the overall data.
Yeah, true. So I have been working with tweets, and we are collecting 20 million tweets per day.
Right.
And we show the top tweets, and we know that the top tweets, and if it's negative, it's not negative, it's sarcasm. So actually, I can assume if you're doing this again, try to make the happy emoticon as a negative.
But the question is still though, to do the evaluation, you need to gold annotate.
Definitely, yes.
Right. So do the gold annotations actually say the happy sarcastic face is negative? In fact, I mean, you have to say that.
And actually, she mentioned 37% was against the.
It was a reversed.
A reverse, yeah. So, but actually, my assumption is not to classify them to positive and negative. Classify to sarcasm and.
Yeah, this is another whole way of research of sarcasm and irony. Yeah.
I totally agree, but the main thing that we are trying to do the wrong classification. It's not positive and negative. It's really hard.
It's just maybe worth point out that in Arabic it's less effective because in English, just using emoticons it works and reaches accuracy up to 83%.
I have seen this, and actually I applied in some tweets in English, but for the Arabic, it's totally.
Yeah, maybe it's worth mentioning that to the rest of the world, that Arabs are not using emoticons in the right way. But I have noticed that in the previous example that emoticons are being used truthfully. Actually, the text is being used sarcastically, which is the tricky bit. So if we take the emoticons away, it will be, for example, the first one, it will be positive, but it's not. You see my point? Yeah.
Of course, yeah. And just a suggestion.
Thank you very much.
Thank you for the nice work.
Thank you.
Thank you.
Thank you.
I think it's time.